studied the case of postnominal that in non-complement clauses and relative clauses. So this is a work that I've done with Nicolas Ballier from the formal linguistics lab at Université Paris-Cité. I will start by defining some research questions and the material and methods that we have used. I will also give a global overview of our solution. And then I will talk about the two algorithms or heuristics. And finally, I will present the results, the conclusion, and also some discussion. So English has two types of clauses, relative clauses and non-complement clauses. For part of speech tagging systems that are based on trigrams, this distinction can be challenging to make. And this is also an issue for information retrieval systems, as conceptual argumentation makes heavy use of complement clauses. So on the left, you can see a relative clause, the man that I saw, whereas on the right, you can see a complement clause, the fact that I saw a man. Let me also define clause modifier of noun, labeled ACL, RLCL, in the universal dependency annotation. And the relative clause modifier labeled ACL. So on the left, you have the relative clause which you bought that modifies the nominal, the book, whereas on the right, the finite clause as he sees them modifies the noun, the issues. So we see later the usefulness of these two annotations and how they helped us in our study. So corpora are valuable to investigators, and they are widely used in NLP and speech recognition and integrated language systems. So the quality of an NLP system is significantly dependent on the quality of the corpus. The Pentry bank is probably the most used tag set. So we have used its annotations. We have also used the Brown corpus from the Analytica library with its 1 million tokens. So we based our experiments on the universal dependency annotations, and our output model is a probabilistic decision tree, which is the tree tagger that makes part of speech tagging. While the Pentry bank is comprehensive, it doesn't make the distinction between that as a relative pronoun and that as a complementizer. Even though the clause 8 makes this distinction using the WVPR label for relative pronoun that and CST label for complement that, it is not free, and as far as we know, the precision and recall have not been reported. So the question that we asked at the beginning of our study is, how can we make this distinction between the relative clause and complement clause that in an automated way so that the result can be reproducible on other corpora? So the idea is to fine-tune a probabilistic decision tree, which is the tree tagger, by providing an annotated corpora, which is the Brown corpus in our case, that will encode this distinction. So here we have the annotated Brown corpus, and we will use some algorithms or heuristics that I will present later. And the idea is to train the model that will be able, given any corpora, it will be able to annotate the corpora with the aim of distinction. So we have implemented two heuristics. The first tries to emulate the enhanced dependency graph. So the annotated depths in the UD annotation based on the part of speech and the dependency relation. The second heuristic tries to re-annotate the Brown corpus. More specifically, it tries to encode the WVPR, which represents the relative that, and CST, which represents the complement clause that. So the idea is to allow the tree tagger to make better distinctions. So the first algorithm or heuristic create the depth column by combining the information of the head column, which is just which represents the identification of the token to which the current token points to, and the depth column, which is just the dependency relation. Adding to this, we also verify that if that is after the token to which the head points to, we make sure to concatenate that to the depth column. So the first heuristic was applied to the English GAN corpus on the 3 available files on the GitHub repository, so train, dev, and test. And we have computed the accuracy. As you can see, compared to the ACL or LCL, the ACL label is more complex to build, which gives a hint about how challenging it is to annotate the complement clause that. So for this study, we have used a part of speech tagger. So we won't be using this information, which is the enhanced dependency graph, but it is really interesting information to include in a tagger that uses this information. And it also gave us an interesting information about how challenging it is to annotate complement clause that. We'll see later some results. I would pass to Nicolas.
Yeah, let me just, can you stop sharing your screen so that I can share mine? And that'll be perfect. You need to stop sharing. In the first experiment, we've tried to identify non-complement clauses and relative clauses using the parsing structure, so the universal dependency. In the second series of experiments, we have tried to identify relative clauses and non-complement clauses by assigning them the proper POS label, the proper part of speech tag. And to do this, we've used the functionality of a tree tagger that allows to learn a tagged corpus and to build the tagging with the desired tag sets and the desired tags. So to do this, we have used some of the codes used in the close tag sets, which has CST for that, which only correspond to the conjunction in non-complement clauses, the fact that. And we've used WPR for relative pronoun as a tag for the that serves as a relative pronoun. And the experiment tries to see if we manage to build this distinction. And the pipeline that you see is uses a re-annotation of the pen tree bank with the modified tags for CST when they correspond to non-complement clauses and to WPR when they correspond to relative clauses. And then the algorithm does tree tagger, can tree tagger really learn this distinction? That's what we try to build. The results shows how we have gradually used an increasing number of files, and that's the horizontal axis for the different files corresponding the re-annotated elements, and the more annotated files we use, the better we would expect the accuracy to raise. This is more or less the case for the labeling of relative pronouns. That's the green screen capture on the left. For the category relative pronoun, we seem to reach a plateau when we reach about a fifth of the Brown corpus, and we've counted that in number of files. But for the learning of the realization of that as a conjunction in the noun complement clauses, we can see that the accuracy degrades progressively, and we can account for this by the fact that we have kept the various other labels that are used in the pen tree bank for that. The first label, in a way, competing label is in, which corresponds to that being a conjunction, but also a conjunction used for verbs, like I say that. This is true. These are the two labels that we try to learn, CST and WPR, but there are also competing labels. The realization of that as an adverb, it's not that easy, where that is actually an adverb. The WDT, which is potentially a relative pronoun, and DT, which is both the determiner, that guy, and I don't like that, the proform uses of that. So these competing functions makes it more difficult for the tagger to learn the new distinctions when some cases overlap, namely in partially corresponds to the that being used as a conjunction, and WDT partially corresponds to relative pronoun. So our new labels provided in the training files are not that easy to learn. One of the factors that have definitely involved an explanation for the discrepancy between these results is the fact that the distance between that and the corresponding nouns can potentially be different. For relative clauses, the that tends to be very close to the antecedent, but we may have intervening tokens, such as a relative clause, between a noun and the that of the complement clause. So that's a definite factor for explaining why the that corresponds to WPR are in a way easier to learn, and they're closer and easier to determine. Now, there are some points about our method. The first one is we used relabeling techniques instead of learning from scratch. And maybe if we relabel all the labels with only WPR versus CST, we may get a better score. The point is that because that has many potential functional realizations, that makes the task pretty hard. And maybe we should have constrained some of the relabeling that we use to predict our CST and or WPR label. Another crucial aspect is the use in the universal dependency theory and tag sets of the ACL label, because we've seen that it also includes some structures that are not just simply non-complement clauses with that, such as clauses with as. And one potential solution would be to acknowledge a subtype of ACL, the nominal clauses, that would only be restricted to non-complement clauses. So we would have a similar situation where the ACL is subdivided currently into relative clauses and could be also subdivided into non-complement clauses. As to the rest of our research, we would like to analyze other UD tree banks because we've only looked at the performance based on the GUM tree bank for English, and there are at least 8 tree banks for English. And if it's a tricky distinction, maybe other tree banks have actually paid more attention to this. We've seen that in some cases, the noun and the that can be separated from non-complement classes, and we'd like to pay specific attention to this. And we've only looked at the tagging of that and the non-complement clauses that had a that, but there's also cases where the complementizer is not othered, so sometimes called a zero complementizer, as in the example we gave, plus the fact that I'm covered to be found in spoken data. So in that case, we know that to try to analyze whether we're non-complement clauses. And our conclusions is we've evidenced that non-complement clauses are more difficult to detect than relative clauses. And we would like to insist on the fact that global accuracy rates reported for tagger systems tend to avoid mentioning that some more complex cases like that are actually more complex to tag. So the A is easy to tag, but not necessarily the case of that. And if we want to have specific labelings for the that realizations, it is a truth universally acknowledged that a man of good fortune. All these cases of extrapositions may also need to be taken into account as a special label. And here are a couple of our references. And the code is to be displayed on the GitHub created by Zineddine, and we'll be happy to have your questions. Many thanks.
So thank you very much. Can you hear me with this back on?
Yes.
Okay, great. So while the audience is thinking, so the question I had, actually you touched on in the sort of future work. So I was thinking about null complementizers in the Penn tree bank, which is another resource that does mark the sort of zero noun complement case. So do you think that sort of constituency representation, could be another useful resource for exploring this? Or there are some,
yeah, and undeniably, if we want to look at the zero complement clauses, we cannot play, we cannot use that, and therefore having the universal dependency structure and tagging will allow us to detect those candidates for potential zero non-complement clauses. So definitely, yes, universal dependency parsing for the detection of this kind of structure is really a must.
Okay, other questions? Let's see, I'll check also, nothing on chat. There's one question over here, just a moment. No, you can't see, so I'm running the microphone over to someone.
Hello, thanks for your presentation. Not sure if my question makes sense. So you're saying that the universal dependencies, so do you think not using the universal dependencies, having some language dependent labels and relations will help you? So because this seems to be a language dependent problem. So when you go into the universal dependencies, you go into a more abstract representation, and I wonder if the language-specific features will help you in any way.
The contention, if any, about the universal dependency set of labels is the fact that for these kind of non-complement clauses, they have actually varied. In the initial days, they used to regard the fact that it was a noun and labeled it as a complement. So it used to be labeled as C-comp. And then they say, that's not a complement because it's not a verb. And therefore, let's change this label to ACL. We may argue with this point if you believe that if you call that a complement clause, that really is a function of a complement, and therefore there's nothing wrong with considering it as a complement. And from that point of view, that could still be universal, even though in some languages like Korean, the distinction between relative clauses and complement clauses is not that clear, as evidenced by a paper by Comrie.
Okay, I think there are no further questions, so let's thank the speakers again.
Thank you.
Thank you very much, and enjoy the rest of the conference.
Thank you very much for the organization, and goodbye.
So now we'll hand over to an in-person speaker. So I will, this was actually kind of tech help. Do I need to do anything with Zoom here? Or?
No, is it being copied? Yep.
Share screen.
Yeah, and then share screen. And...
Okay, so now we'd like to welcome the